In this lesson, we're going to go over solving systems of linear equations working with three variables. Our objectives are to understand systems of linear equations in three variables, and then we'll learn how to solve. Okay, so systems of linear equations in three variables. So when we did systems of equations in two variables, we were talking about two lines and where those two lines intersect. Now that we're working with three variables, we're talking about where three planes, which you can think of as a sheet of paper that extends in all directions, the ordered triple XYZ of where the three planes intersect. So if you have an ordered triple XYZ, it must satisfy all of the equations in the system, and then we'll continue to use substitution and elimination methods to solve the system. So let's talk about the possible solutions and the meaning of it. So if we have one solution, that means the planes intersect at one point. And if you look at the ebook in chapter 6, I believe, there are nice visuals of these. If there's no solution, that means we have that the planes don't intersect, so we have three parallel planes. And if there's infinitely many solutions, it could mean two things. It could mean that all three planes are identical, or that the planes intersect and form a line. So rather than just intersecting at one point where there's one solution, the planes could intersect and form a line. Okay, so when we're solving a system of linear equations in three variables, our goal is to get it into a form like this, where we have one equation that has all three variables, one equation that has two variables, and one equation that has one variable that is known, this z equals -3, so that we can use back substitution, plugging that into the second equation, and then we'll find y, plug it into the first equation to find x, so that we can find the value of x, y, and z. So we know that z is equal to -3, so we're going to use back substitution and plug it into our second equation. So we have 5y plus 4 times z, which is -3, equals 13, and then we solve from here. So we have 5y minus 12 equals 13, and we will add 12 to both sides to get 5y equals 25. So 5 times what is 25, or divide both sides by 5 to get y equals 5. Okay, so now we know that y equals 5. Now that we have z and y, we can plug those into the first equation to find x. So we have x plus 2 times 5 plus 3 times -3 equal to -1. And then we simplify and solve from here. So we have x plus 10 plus -9 equals -1. This gives us x plus 1 equals -1, and then we subtract 1 from both sides to get x is -2. So our solution here as an ordered triple would be -2 for x, 5 for y, and -3 for z. But see how this form was really helpful. Once we knew the value of one of the variables, we could back substitution into the equation that has two variables, one of them being the one we know, and then finding both of those and plugging it into the first equation. Now you don't have to have x, y, z, and then z. You can use you can have this in any kind of form. Well, the first one would always have all three, but let's say you had x and z and then you knew the value of z. You would still be able to work with this. Okay. So the strategy here in general is we're going to use substitution and elimination. What we'll do is we'll choose one variable to eliminate from two different equations, because what that is going to do then is we'll have one equation, we'll have three variables, okay, and then equation 2 will have two variables, which will be the same two variables as equation 3. So for instance, what this could look like would be x plus y plus z equals 1, x plus 2x plus z is equal to 7, and let's say 5x minus 3z is equal to 11. So something like this, where you have one equation that has three variables, and two equations have the same variable that's been eliminated. Now what you can do is, going back to the previous lesson, we have two equations and two unknowns here. We have x and z in equation 2 and x and z in equation 3. So then again, we can use those two equations to eliminate one of the other variables, giving us the form that we talked about on the previous slide. So let's see what this looks like. We'll go through a couple of examples. Example 2, solve the system of equations. So we have x minus y plus z equals 5, 2x plus 2y minus 3z equals 31, x minus 3y plus 2z equals negative 26. So what I'm going to do in this case, just to show you how it would work eliminating a variable other than x, is I'm going to eliminate y from equations 2 and 3. Eliminate y from equations 2 and 3. So the first thing I'm going to do is I'm going to take, this is equation 1, equation 2, and equation 3. I'm going to take 2 times equation 1 and add that to equation 2. Okay, so this is what I'm doing. 2 times equation 1, and I'm going to add it to equation 2. So 2 times equation 1 means I take everything in equation 1 and multiply it by 2 to give me 16x minus 2y plus 2z equals 10. And then I'm adding that to equation 2, which is 2x plus 2y minus 3z equals 31. So I add these together, and I get 18x, the y's cancel out, minus 1z is equal to 41. Now we have a new equation. This equation can either replace equation 2 or equation 3, but not both. So I am going to have it replace equation 2. So now what I have is I'm going to have the original first equation, my new second equation, and then my original third equation. Okay, so I'm going to put that on the next slide. So going back to the strategy, this is equation 1, equation 2, equation 3. I'm going to eliminate y from equation 3, so that way, once I replace that equation, equations 2 and 3 will have the same variable eliminated. Okay, so the way I'm going to do that is I'm going to take equation 3, and I'm going to add it to negative 3 times equation 1. Okay, and the reason why is because I want the y's to cancel out. So I need a positive 3y and a negative 3y. So everything here gets multiplied by negative 3. So now I have negative 24x plus 3y minus 3z equals negative 15. And then I also have my equation 3, which was x minus 3y plus 2z equals negative 26. Okay, and so I add these together now. Negative 23x, this becomes minus z is equal to, this is negative 41. Okay, and this is now going to replace equation 3. It can replace either one that you worked with. I'm just choosing to replace equation 3. You could replace equation 1, but again, it's replacing equation 1 or 3, not both. So on the next slide, I'm going to write what our system now looks like. Okay, so again, remember I talked about at the beginning that the strategy was to eliminate the same variable from 2 different equations. We've done that. Equations 2 and 3 do not have y, so that same variable has been eliminated. Now we can use the 2 equations in order to eliminate x or z, and that way we will solve for one of the variables. Okay, so in order to do that, I am going to take, this is equation 1, equation 2, equation 3. I'm going to take equation 2 times negative 1, so negative 1 times equation 2, and I'm going to add that to equation 3. Okay. So negative 1 times equation 2 is negative 18x plus z is equal to negative 41, and then equation 3 is negative 23x minus z is equal to negative 41, and I'm going to add these together. This is going to give me negative 41x is equal to negative 82. So then if I divide both sides by negative 41, I'm left with x is equal to 2. Okay? So I just found the value of one of my variables. And again, this is technically an equation, so it can replace equation 2 or 3. I'm just going to have it replace equation 3 and go to the next slide to write the system. Okay, so this is my desired format. an equation that has one of the variables known, we can back substitute into the second equation to find z, and once we know x and z, we can plug those values into the first equation to find y. Okay, so first what we're going to do is find z. Let me erase that and start that over. Find z. So we're going to substitute x into the second equation. So this is 18 times 2 minus z is equal to 41. And then we solve from here. 36 minus z is equal to 41. We subtract 36 from both sides. And I'm going to go up here. Negative z is equal to, this would be 5. Okay. So then I get divide by negative 1. This means that z is equal to negative 5. Okay, so now the last task is to substitute both x, which is 2, and z, which is negative 5, into that first equation. So now, find y. Okay, so we have 8. We know that x is equal to 2, minus y, which we're solving for, plus z, which is negative 5, and that is equal to 5. Okay, and we solve from here. So 8 times 2 is 16. Minus y plus negative 5 equals 5. Okay, so this gives us negative y plus 11 equals 5. Okay, and then we subtract 11 from both sides to get negative y is equal to negative 6. Divide by negative 1, and we get y is equal to 6. Okay, so if we put it all together, I did leave myself another slide. We have x is 2, y is 6, and z is negative 5, which means these three planes intersect at one point. So our solution here is 2, 6, negative 5. Okay, and the way you can check your answer is plug it in, x, y, and z, into each of the original equations and make sure it satisfies all of the equations. Okay, let's do one more example. I left myself plenty of slides. Solve the system of equations. So we have 4x plus 3y minus 2z equals 1. 12x plus 9y minus 6z equals negative 10. And 2x minus 4y plus 3z is equal to 4. Now something to take note of here is these appear, some of these variables in each of the equations appear to be multiples of others. So for instance, 4 times 3 is 12, 2 times 2 is 4, 3 times 3 is 9, 2 times 3 is 6, and so on and so forth. So when that happens, so for instance, 4 times 3 is 12, 3 times 3 is 9, negative 2 times 3 is negative 6. When that happens, I would start with those two equations to see what's going to happen. Because if we add or subtract them together, a lot of things are going to cancel out. Okay. So what I'm going to start with then is I'm going to multiply equation 1 times negative 3, and I'm going to add that to equation 2. Okay, so equation 1 times negative 3, remember everything is getting multiplied by negative 3. So this is negative 12x minus 9y minus 6z is equal to negative 3. And then I have my equation 2, which is 12x plus 9y minus 6z is equal to, oh, this should have been a positive 6z up here because it's times negative 3, is equal to negative 10. Okay, so if I add these together, negative 12x plus 12x cancels, negative 9y plus 9y cancels, and 6z minus 6z cancels, and that's negative 13. So we have 0 is equal to negative 13, which is not true. Okay, so this would be a case of no solution. Okay. If you would have started off choosing a variable to eliminate, you may take more steps, but we should still get to the same final result. I think I left myself a few slides. Thank you for watching. If you have any questions, please feel free to reach out to me.